Good morning, everyone. Welcome to the August 2025 Zoom Citrus Seminar. Thank you for joining us. First, I would like to thank Julie Carson from the UF-IFAS Center for her help and cooperation. Today's program offers 1 CEU for pesticide license renewal and 1 CEU for certified crop advisors. If you need CEUs, email me your name, email address, and license number. The title of the seminar presentation today is Breaking the HLB Cycle, CUPS as a Practical Solution for Sustainable Citrus Production. Our guest speaker is Dr. Arnold Schumann, Professor in Soil, Water, and Ecosystem Sciences at the UF-IFAS Citrus Research and Education Center in Lake Alfred. Dr. Schumann will discuss the advancements in citrus and their protective screen production systems, highlighting the transition from research to commercial implementation. He will cover the benefits and challenges of CUPS, as well as best practices for Florida citrus growers wanting to use the technology. Among other topics, he will highlight tips for effective pest spraying in CUPS and understanding how hurricane winds affect CUPS structures. Dr. Schumann, it's all yours. Please go ahead.
Thank you, Mongi. Thanks for the introduction, and good morning, everybody. I always like to start off with this slide because it shows the impacts of the research that has been conducted towards citrus on a protective screen and the practical impacts, especially for growers. So starting off with inputs, what's been funded way back in 2014, we got the seed grant from the CREF, Citrus Research and Education Foundation, which kickstarted the whole program. It was $50,000, and then you can see USDA has contributed multiple times with competitive grants, and so has Florida Department of Agriculture Consumer Services, and that's the Citrus Initiative. And the big one was the ECDRE, which is the federal fund for emergency citrus funding. Totaling about $4 million, and the outputs and the impacts on the industry have been about 1,500 acres of CUPS have been built so far, to the tune of about more than $100 million in value. So it's a big investment. Grapefruit yield, once in full production, is about 1.2 million boxes per year out of that amount of CUPS, with about an excess of $30 million of net fruit revenue per year. For nursery trees, at least over 545,000 trees have been planted in the CUPS, worth about $5.4 million. 2 spin-off companies were formed as a result of the CUPS research, and 2 registered trademarks were formed. You can see them here, Eco Grown and Florida Rubies. And I can safely say more than 200 growers have benefited from this, largely because of the Dundee CGA, being that it's a cooperative with many members, so they've all benefited from it. So let's start with this video and show you the inside of one of the CUPS. This happens to be Dundee. Let's just hide the controls here. I'll carry on. There we go. So this was at bloom time, as you can see. At the time, these trees were, I believe, probably about 6 years old, 5 or 6. And then a few weeks later, you get fruit development, of course, stage 1. And this is just an example taken real recently, June 24th of this year, showing the fruit sizing. That's pretty good for June fruit. Here's another slide of it. This is in July from a different cups. It's already reached marketable size. And here's another video. These trees are 2.5 years old. And the video was taken here on July 16th, just a month ago. So it's easy to see that the growth and the production is much faster and higher than even conventional citrus that was grown 2 decades ago without HLB. It's greatly accelerated production. And just a quick view of the final product at maturity. Okay, that gives you a glimpse of that. Now, going back to Dundee, I just want to show you the harvest season, which I happen to have photos of. That I was very impressed by the lack of fruit drop, almost nothing on the ground. And this was not a hurricane year, no. But even on a hurricane year, there's negligible to zero fruit drop because the cups protects the trees and the fruit from the winds. And so part of what I want to show today is how the research led us to where we are today, and then also how the commercial adoption helped to get us to where we are today with more than 1,500 acres of cups. So we've worked, it's been a transfer of technology from research to commercial use, but it's also been a return. It's been a feedback loop where the commercial growers have worked with us to improve our research. So this is where it started, at least for the CREC. There's another cups. It's actually 4 units that are down at the Indian River. They were built about 8 months before this one, but this is the first contiguous 1 acres of cups that I know of, and that was at Lake Alfred. So the actual size was 1 1/3 acres. So the specs are 14-foot height, 200 by 290 feet, making it 58,000 square feet, or 1.3 acres. It consists of poles on the inside, they're spaced at 30 feet, and at the wall it's 15 feet spacing. Make sure that when you build cups that you leave, of course, space inside for tractors to turn, especially at the so-called headlands where the tractor turns it from one row into another. So we left 20 feet, that's worked really well. And we also left 14 feet at the sides, between the side wall and the rows. That gives us a 74% plantable area, which is 1 acre. And I will talk more about the economy of scale, how that number of 74% improves up to the 90% if you build larger cups. There's economy of scale involved here, so I'll be dealing with that in detail. Just a few pictures first. Here's at 2.5 years, we ended up growing all our trees initially in pots because we saw a really remarkable system with potted hydroponic citrus in California, and we more or less copycatted that, and it worked really well for 5 years for all varieties. And then at about 5 years, the grapefruit started getting pot bound. So we had to, as you can see, they're doing still very well at 2.5 years. But we had to abandon that idea and plant them all on the ground. But we didn't lose a single tree. So the top varieties have been grapefruit for various reasons. It's very tropical. It loves the heat in the cups. And it's done extremely well, and it's very profitable. So we've evaluated Flame, Ruby Red, and Ray Ruby grapefruit, and they've all done very well. So here's that root bounding or crowding problem that I explained at about the 5th year onwards. We noticed a decrease in fruit size for the grapefruit on both rootstocks that we have, US 897 and Sour Orange. And that was unacceptable. Grapefruit needs to have a certain size, especially a large size, is highly favored. So we replanted all these potted trees into the soil in 2020, and they recovered immediately. The very next year, 2021 to 22, at age 7.5 years, they were putting on a massive yield, beautiful fruit, large size. Net revenue for that year was $20,000 per acre. That's net revenue after all expenses of harvesting and packing have been paid for. Packout was close to 100%. I think it was 99% that year. The one rootstock sign combination that has continued to do remarkably well in pots is this X639. To this day, we still have it in pots at the 11th year. And it's at a very crowded high density, 4 feet by 8 feet spacing, giving you 1,361 trees per acre. So I think it's an exception. We would perhaps it's a lucky combination of factors. I do believe X639 benefits from the dwarfing caused by the pots. And here's the yield to show it. It's the pinnacle of our yield that we've achieved out of any combination in the cup so far. So let me just hide the panels again. It keeps showing up. So cumulative yield over 10 seasons is 9,308 boxes per acre. So you can see from inception, from planting, it's been able to yield, averaging over those years, all the way from planting, it's 930 boxes per acre per year. So over 10 years, 9,300. And so you can see even in the first year, there was over 100 boxes per acre, and then it's averaged around about 1,000, the long-term average, 1,000 boxes per acre per year. All right. Now, fruit quality, I mentioned fruit size as being very important. What I've got here is a frequency histogram. The y-axis is frequency. On the x-axis is fruit size and the traditional packing house units, 56, 48, 40. Those are the smaller fruits. Going to the largest fruit are 27 and 32. And you can see, fortunately, in these cups grown grapefruits, they're being the Ray Ruby. In this example, year given January 2022, 85% of the fruit were in those highly profitable, desirable classes. You can see the prices for each per box. Yeah. I'm sorry, per carton. Let's get that right. The bottom axis reads correctly. It's a fruit count, and it's also the price per box. Yeah. Yeah, per carton, as it says down here. FOB food prices received per carton. So remember, a carton is approximately half a box. So that's a pretty good price. And packout was 98% that year. Now, net return per field box was $24 after all the expenses have been paid. And so very few small fruit and almost none that do not qualify for packing and shipping. So I wanted to in that same vein, I wanted to just discuss briefly what we've observed with two rootstocks that are being used for our Ray Ruby and how they affect fruit size and also yield. And it's to do with vigor. So here, these are the same trees planted in 2014, but I've only shown you the more recent years from 2018 to current to 2025. And you can see there's been some ups and downs. This is fruit yield. And caused by various things. They were pot bound here, so the fruit size was down. Then in 2020, they were transplanted, so there was a brief downturn because of recovery from transplanting. Notice that hurricanes have no effect on the yield. Irma and Nicole in 2022, no effect. Likewise, Milton last year, no effect. And even if you go back to the beginning here, Irma had no effect leading into 2018, which was the post-hurricane year. So hurricanes have no effect on the yield. It's other things. And what's worrying us here, what I'm pointing out, is the red line is sour orange. The blue line is US 897, which is semi-dwarfing. And you can notice that the yield, there's a downturn in yield, and it's starting in about the 8th or 9th year with sour orange. And I've attributed it's very evident that it's all due to excessive vigor, excessive vegetative canopies, and not enough bloom. It's not a case of not enough fruit set, it's a case of not enough bloom. So here's a different plot showing the fruit diameters, and you can see, sure enough, a symptom of less fruit is larger fruit. And besides, sour orange is predisposed to produce large fruit. But notice that it had similar sizes for earlier years, and then things are starting to go crazy here in recent years. So that's fruit size. Look at fruit quality. Soluble solids have also shown a recent trend. So you notice the two lines follow closely until recent times. The last 2 years, there's been a divergence, and the larger fruit have a lower quality than the smaller fruit. So it's a real problem. And you can even see it. We have drawn the yellow line in this slide. You can see in the background is a sour orange, and in the foreground is US 897. You can see the trees are much larger, and the amount of fruit in them, especially this year, is remarkably less than in the US 897. So there's a question of precocity and also the dwarfing, the benefits of semi-dwarfing rootstocks. The surprising thing is how late in the lifetime this occurred, only after year 8. So you notice nothing wrong until year 8. So look out for early warnings and maybe take precautions. Don't use vigorous rootstocks. So for long-term canopy size control and cups, something like US 897 continues to be a good choice of rootstock. How do we manage the more vigorous rootstocks? Well, there may be some horticultural methods we could use. So far we have tried canopy size, height reduction with annual topping, and I must point out we used manual pruning for the last 2 times because we realized that machine topping tends to just continue the problem because you get massive sprouting and it becomes more and more vegetative. So we've started using manual pruning once we realized that there's this problem. But so far that has not been the solution. We also tried to set additional fruit using gibberellic acid at bloom to see if that would force more fruit production rather than and suppress foliar production. And we also want to try urea sprays in the winter to induce more flower bud induction. And we can also try girdling. I am very confident that girdling will work, but of course it's a very labor-intensive process. But for academic reasons, we will give it a try. So take-home message here is it is essential to manage runaway vigor and vegetative growth patterns because they can reduce fruit yields and quality while wasting resources. So here's just a couple more photos to illustrate our research cups. Top varieties, like I said before, Flame, Ruby Red, and Ray Ruby. Grapefruit, there's the Ray Ruby grapefruit again. Very good quality. But there's been a lot of other varieties too that we've tested too. We've tested over 20 over these years. Here's Murcott, also known as Honey Murcott, with full color break on December 2020, which is kind of early. It's usually a January, February, March variety for picking, but sometimes as early as December, although this is end of December. So that's Murcott. W. Murcott, a different variety, is a little earlier than the honey. And you can see it's got, in this year, it had beautiful color formation. Most years it struggles with color break in Florida. So that's really its main problem. Is the external appearance. It doesn't often break color. It needs to be cold winters. Here's Dancy. Dancy has no problem breaking color. Very beautiful internal quality and good yields also. Early Pride it's a great variety. It's ripe as early as and harvestable as early as late September, October. Big problem is fruit splitting. Just like its relative fall glow, that variety also splits, and it's a massive amount of splitting. So beware of Early Pride if you're thinking of using it. Speak to us or speak to the growers that are using it. Temple does really well. It's an old variety. It's seedy, but the quality, internal quality is really good, and the yields are reasonable. And here's Mineola. So far, we only have about 15 trees, but they've done really well, as you can see here. It's a very popular variety. Sugar Bell has done really well. Again, another slide here. Although it has strong alternate bearing, you notice this year it was loaded. The very next year there were negligible amounts of fruit on the tree. So that has become a problem. It kicks into an alternate bearing cycle very easily. And then lastly here, Valencia, we're really interested in this one. Now, Hamlin, we've also tried, and Hamlin puts on great yields. The quality is much better than outdoors. It's quite excellent, actually, once the trees are mature. No problem with that. But, it's Hamlin. It doesn't have good color. The juice does not have as good a color as a Valencia. So we're really interested in Valencia. These are actually reset trees, and I showing you on the left here. The tree is only 2.5 years old, and it's already grown to that size, and it's actually in a reset space. So it doesn't have ideal space for growing. It's between two big trees. And this photo was taken in January of 2025. They're not expected to be as high as grapefruit, the yields, nor as high as Hamlin, but the quality is really good. High quality for both juice and fresh fruit. Here's an example of 10-year-old mature Valencias that we have. Soluble solids was 10.7 to 11.8 this last year, and acid was 0.81, giving a very good ratio. Now, the younger trees we have obviously have lower quality, but they'll pick up and get better. So let's talk about hurricanes then, as I promised. So this is Irma in 2017, and you can see it broke some cables, causing everything to sag, and that then starts tearing some of the fabric. But fortunately, we've been through 4 hurricanes over these years since 2014, and we have not had catastrophic damage yet. It's been substantial, severe damage, but not catastrophic. So this is some of the smaller damage you see. There's a lot of movement going on for 24 hours in a hurricane wind, and so any exposed metal touching screen is going to cause chafing and wear. It's fairly minor. This is more severe. This is caused by lifting of the poles out of the ground from the storm, and I'll explain how that happens. And then it tears the screen, of course, and the poles end up, being raised above the ground instead of being back in their holes, and it causes chaos, and it distorts everything. And this is from movement of screen, and those nails, which were, I think they're probably roofing nails that we used to attach it to the pole, that caused tears in the screen. So the roof lifting principle is caused by the Bernoulli's principle, illustrated here really well from an aircraft wing. It's the same principle. Picture an aircraft wing like this with the direction of flight to the left, right? So the air moves from left to right over the wing. What happens is that you have high velocity airflow over the top, higher than below the wing. Below the wing is a lower velocity. The reason why they're different is because of the shape of the wing. Is a longer distance across the wing on the top than there is below the wing. So anyway, high velocity causes, according to Bernoulli's principle, causes low pressure. Low velocity on the other side causes high pressure. And so guess what? The net result is lift due to pressure difference. And as you know, it's very substantial. At a high wind velocity, like a jumbo jet flying or something, it's massive. It can lift hundreds and hundreds of tons. So not to be trifled with. So what happens with CUPS? Same thing. We have uninhibited wind over the top of the roof, going at whatever speed the storm is throwing at it. And then there is a lot of wind is entering through the screen, because it's permeable, through the walls. It's being slowed down substantially. So you get this differential, high velocity on the top, low velocity on the bottom. And then the high pressure accumulating below the roof, it's lifting it up. So that's as simple as that. It's just aerodynamics. But it's very powerful. So in September 2017, after Irma, we learned a lot of lessons. That was our first major hurricane. We made repairs and improvements to the CREC CUPS. For example, we installed these turnbuckles to all the anchor cables, which with a simple twisting motion with 2 spanners, you can tighten every cable very quickly without having to undo anything. Other suggestions or things we learned is that we doubled up cables at the corners of the CUPS. We used longer ground anchors. I think we ended up using 8-feet anchors. And something we haven't done, but other new CUPS, people that are building commercial CUPS, they're doubling up on anchors on the internal poles. So instead of just 1 anchor, they used 2 per pole. So there's a lot of improvements with strength you can make. There's very little you can do about the wind. Wind breaks would be prohibitively large, and they would probably cause damage to the CUPS if you put planted wind breaks around the CUPS. There's only a certain distance, horizontal distance from a windbreak that it actually gives any protection, and I don't think it would be enough certainly not for the size of commercial CUPS. So windbreaks aren't really an option. Okay, let's look at the transition then from research CUPS to commercial CUPS and some of the calculations that we need to account for. Here's just another view of this CUPS. Looks like one of the Dundee CUPS taken this year in June. Age 7 years trees. You can see how large and beautiful they are. And here, as I said, is already fruit that size to a point where it would already pass for the packing house. Yields are average at about 800 or more boxes per acre. And here's a brand new cups, aged 0.2 years. The photo I took was in June of this year, and it's a cups of 240 acres. Okay, so let's get to the construction. Tips for design and cup structures. Let's imagine on the right-hand side we have this old abandoned citrus grove where I'm outlining it with a mouse. And we want to fit cups in, like the blue rectangle there. The size I've measured on Google Earth is 2,607 feet by 634 feet, making it about 38 acres. A ratio of length to width is about 4.1 to 1 in this example. And then, as I've illustrated here, is it better to build one large elongated cups like on the left, or is it better to have four smaller cups, more or less square type shapes on instead of that? So we have to take into account economy of scale. As the size of cups increases, the construction cost per acre decreases because the perimeter increases at a slower rate than the area. That's just a fundamental principle. Also, as the length to width ratio increases, the cost of construction increases because a square is the shape with the lowest cost. And you can think of it just like a water droplet is nature's most perfect shape, a sphere, for the lowest surface to volume ratio. And that's what forms a droplet. And bubbles do the same. So likewise, a square, in terms of the sharper geometry, not using a circle, is actually the most efficient confinement of that space by a perimeter. And that's one way to how to phrase it. Okay, so cups perimeter calculation is really easy. It's 2 times length times 2 times width, as you can see here. But we can also calculate it from the area and from the length to width ratio, which is really what we want, because we want to build a relationship between the ratio, the shape of the cups, and also the area of the cups. So if you juggle things around and you do some substitutions, you come up with this slightly longer equation, but it works, where we take perimeter as being twice the square root of the area, multiplied by, in brackets here, the ratio of length to width plus 1 divided by the square root of the ratio. And it's all explained here. So that's just the equation we use in order to get some graphs. So on the y-axis, we have perimeter of the cups greenhouse, which is what one of the factors that affect the cost. So we need to know that. And then we look at how that changes with cup size. And as I pointed out earlier, the larger the cups gets, the significance of the wall cost decreases at a faster rate than the area increases. Anyway, so if you look at what this graph shows, it shows cup size on the x-axis and the perimeter of the cups on the y-axis. But furthermore, it also shows the shapes here. And you can see, as I pointed out, square is the most efficient shape. It has the lowest perimeter for any size of cups, which is going down this line. Likewise, a 5:1 ratio, a more elongated cups, has a higher perimeter for any size. And then going to a 10:1. So I just showed 3 examples here. So in conclusion here, perimeter increases non-linearly with cup size in acres. Perimeter increases as the length to width ratio increases. So there's 2 things happening there. So what about, let's look at the cost then. That's more important. Let's put all those ideas together and look at cost calculation. Let's look at the existing example. 2,607 times 634 feet, making 38 acres. Remember, it was a 4.1 to 1 ratio. So I plugged all those numbers into the equations and also made some assumptions. And I did this by calibration with the cost of our actual structure at the CREC back in 2014. Okay, it's not current prices, but it's the best I had. So I made sure that these assumptions here would actually work and come up with the same price as we paid. So I assumed a 75 cents per square foot cost for the roof. And remember, of course, that increases exactly as the area of the cups increases. So if you've got an acre of cups, it's 43,560 square feet. And if it's a 75 cents per square foot cost, then you multiply the two and you get $32,000, right, per acre. Again, doing a per acre cost for the wall, we have, again, by calibration, I ended up with $1.1 per square foot for the walls. And it's logical because the walls have more poles in them. They have far more poles than the roof has. So, and poles are expensive. Multiply that by the perimeter, and then multiply it by the wall height to get area, of course, which is 14 feet. Then divide by the 38 acres to get it per acre. And so it seems like a small number. It's only $2,627 for the walls. So total, that's for the acre, for each acre, mind you. So total cost per acre for the roof cost and wall cost is $35,297, which shows up on the graph as shown there with the arrow. You can see there, if you go across, there's about $35,000 and it's at 38 acres. Now, I've drawn two regression lines into these points here to find out where that inflection point is. This is the best way to do it. You basically draw the best fitting lines into those points, and where those two lines intersect, it happens to be 10 acres. So the cup size, like a sweet spot, which is best where for economy of scale, is at least 10 acres. So anything less than 10 acres is pretty detrimental, pretty unattractive type of costs, much higher costs. Economy of scale is not good. So one needs to be at least 10 acres to get the benefit of economy of scale. So let's look at a whole bunch of scenarios here. This is the, again, cost on the y-axis per acre, and looking at both shape and size together at the same time. This time on the x-axis, I've plotted CUPS shape. So it's from ratios of 1 to 10. And then labeled here, each line is a different size. So there's the 1 acre, 2 acre, 5 acre going down the line, okay? There's the sweet spot, 10 acres. And some numbers here for a 1 to 10 shape. And you can see the animations there showing those two lines I'm comparing. The difference between the two in cost is 28%. So 10 acres is 28% lower cost than 1 acre for that ratio, for that shape. Let's go on to a 1-to-1 shape rather than the 1 to 10 shape, so we can compare. Now you notice the highlighted points. It's only a 19% difference. So showing you that the 1-to-1 shape is already quite efficient. I think you get better savings if your shape is more oblong. And that makes sense. It's because it follows the curves. All right, enough of that. So one last question, though. The single large cups, would you say it's better than 4 smaller cups? Well, it would seem with economy of scale, we should go straight for the big one. But there's some other issues that we can consider. So considering the same block again that's available, a single cups of 38 acres, we've just calculated that, comes to 35,297. However, 4 smaller cups, each of 9.5 acres, I've done the calculations on a spreadsheet, come to only 36,841, which seems really close. It's not that bad. Bear in mind, that's per acre. So if you have 38 acres, that differential there gets multiplied by 38, and it comes to quite a bit. Here it is. The 4 square cups cost 4.2% more, or $58,000 more than the single large cups for that size grove. And that's a substantial amount. So it still looks like it's attractive to build the large cups. However, also bear in mind, I didn't estimate the cost of additional doors, buffers, or anything else between the structures and accessories. So there could be additional hidden costs for the 4 cups versus the 1 cups. However, turning the table around here, there are cost benefit factors to consider where actually smaller cups can even be an advantage. So here, the more expensive 4 individual cups can be better managed for pests and diseases. You can spray them faster. You can finish a job in them in 1 day, which is what I would recommend, rather than having to take multiple days. Storm damage can be isolated. So if it damages just one, if there's a big tear in this cups here, the others are unaffected. Pest invasions can be quarantined better, and also cross-pollination can be prevented if you don't want to have cross-pollination of different varieties. So here's an example. This is what Dundee has been doing. They've been doing the very large commercial. This is one of their latest developments, very large cups, and they've chosen to use 10.5 acres, about a 1.4 to 1 length to width ratio. And that's been their plan, and I think it's working well. Okay, so let's move on to the screen then. Another very important consideration when you're building cups. We have tested a number of different screen sizes with some research, and I'll show you the publication in a second. But the two that came out as winners were the 40 mesh and 50 mesh. You can see them there. So that's the minimum requirement. It needs to be 40 to 50 mesh, allowing 80% of visible light transmission. Pros and cons: 50 mesh is stronger than 40 mesh because it's got more fibers per inch, but it reduces airflow. So there are some things to consider there. And here's the full publication in case you need to look at it. Okay, now looking more at pests, looking at the spraying options. You can see on the right-hand side here, this is us spraying in very narrow density, very high density, very narrow alleys in our cups. And we chose to use, for the most part, we chose to use a tower sprayer because it just does a better job. And I'll show you why. Instead of an air blast sprayer, we've used both. Currently, we're stuck with an air blast sprayer, but we're about to change that again. We're trying to get a tower sprayer because we've realized we've got problems with the air blast. And part of the reason we have these needs in our cups is because of the higher densities. 360 trees per acre is what I typically see commercial cups growers using, or higher. So it's substantially higher than conventional, and that means things are very tight in there. Spaces are tight there. The geometry is such that it doesn't work very well with an air blast sprayer. Closely spaced tree rows, like 15 feet, make it difficult to target the treetops with air blast sprayers. Treetops can be refuges then for pests, including psyllids and mealybugs. And we've seen that. We see that all the time. It's a problem. You cannot eradicate them up there. These escape pests can also develop pesticide resistance, which would be a real concern. And as I said before, you want to spray your cups within 1 day, if possible, so that you don't have a layover and pests recovering and then still being a problem the next day. So here's the geometry issues. I took these straight out of a good online site called Sprayers 101. Illustrates it really well. On the right-hand side is an air blast sprayer. On the left is a tower sprayer. Tower sprayer does a good job because it has these angles. Usually they're at about 12 degrees upwards, where the air comes out of the tower, and it sprays between the branches. A much better entry point than trying to spray through the branches, which is what the air blast tries to do. It's going at this angle. Also notice so that's good coverage, even up to the tops of trees. The problem with this was that you can get bad coverage on the tops of trees. Now, you may not find it in the first few years when your trees are small, but when they get to 5 years and they're fully mature, we've seen this problem over and over again. So beware of that. Also notice that an air blast sprayer has a longer pathway of spray from to the tops of trees than to the bottoms or the middles of the trees. And that causes differential problems. It's not the same traveling distance. The velocity of the droplets is smaller because it's traveled further, and again causes problems. Tower sprayer doesn't do that. Another problem is to do with pruning more than anything else, canopy management. This is what the scenario with an air blast sprayer. You notice that if it's a closed canopy with the top of the tree blocked by lower limbs, you get bad coverage on the tops of the trees. So part of it can be alleviated even with the air blast sprayer by just doing better pruning. And that's the desired shape. They're giving good coverage. One more thing with spraying is slower travel speeds greatly improve spray coverage. I think we all know that. That Sprayers 101 all over again. And it's illustrated really nicely here. That's why I included the slide because they do a good job. As a cross-section view, you can see here at slower travel speed, you get beautiful coverage of the canopy. As a top view, you get beautiful coverage. And they call it dwell time. The slower you drive, the more dwell time there is, more penetrating power. And it also gives you a longer throw. And that's because if you look at the higher speed here on the right-hand side, you notice that because of to the forward travel direction and the speed, you get this plume behind the sprayer. It does a very bad job penetrating. And a cross-section view shows you the same. So that's at higher speed. Doesn't give you a good throw. And I think the best way to evaluate all of this, if you are getting proper coverage, especially at the tops of trees, is use water-sensitive paper in the trees and test different speeds and test different scenarios. And what we want to do is get hold of that, our own tower spray, and we'll do some comparisons, and we'll be sharing that with you. We'll be doing water sensitive paper tests to show what the best situation is. So there's a bit more research to be done there. Now, finally, I believe this is the end here. The last thing I wanted to show you is I've created a chatbot for CUPS. It's called CUPSchat, and you can see the link over there. And it's mainly as an extension tool, which is what most of you are about, getting the message out from IFAS. And you can literally ask it anything about CUPS, as the name suggests there. It pools 11 years of knowledge about CUPS from 70 documents so far. And of course, you can easily add more. It can be continuously updated as soon as they're vetted and ready to go. It collates and interpolates information. I can show you that, by including data collected over time in different documents. So it's smart enough to be able to actually collate and combine data across all those years. But however, use it with discretion, like any chatbot. I think it's a good exploratory tool. That would be my recommendation. If you want to make multi-million-dollar decisions, come to us, come to your extension agents, talk to other growers. Get a second opinion, wherever that is. So, because any chatbot in the world at this level of sophistication, which they are at right now, is still being accused of hallucinating. They call it literally hallucinating. So I've never seen anything bad with any of the ones I've used, including this one, but it's known to do that. Now, why do we need our own chatbot for CUPS? Well, it's as I said, yeah, it's a modern extension tool. But if I look at AI, let's say on Google, and I asked it the question, what is CUPS? As you can see here, it has no clue what it is. It says CUPS, which stands for Common Unix Printing System, blah blah blah. It's some computer jargon, right? So that's why we need a CUPS specific chatbot, which is what I created here, because it can give you proper answers. So here's an example. Describe the increase in CUPS acreage for each year from inception to present time, is the question I asked it. The answer it gave is, it said the CUPS project has experienced significant growth in acreage since its inception in 2014, so it discovered that by itself. Here's a breakdown of the increase in CUPS acreage for each year, and what I took, it tabulated the numbers, and then I went ahead and graphed them. And it's pretty amazing. It took this out of 70 documents, well, probably not all 70, but it found the right sources of information, and even pinpointed events like this is the CREC 1.33 acres, and Ed Pines is 20 acres in 2016, and so on. And then in Dundee, and carries on for each year. And I've just graphed it here for interest, and it shows a kind of a non-linear, almost exponential increase at this stage. Here's another example. What is the break-even time for CUPS? That being the economic break-even. Be concise, but show sources of information. And it came back with the break-even point for citrus on a protective screen is around 7 to 8 years. This is based on various studies and reports, including, and I'll show you those because I asked for them. I said, be concise, but show sources of information. And it's sure enough, it shows you here a study by myself and another one there, and so on. All right, so I think I have a few minutes left. I will just go to the actual live. Yeah. Oh, gee, I missed it. Sorry. There it is. Here's the live demo. Okay. And I'll just say, let's talk about CUPS. And that's what it said, citrus on a protective screen, blah, blah, blah. You can ask it to be more concise or more verbose. And it tells you what it's about. It tells you the benefits, challenges and limitations. So it's been quite excited about answering, because all I said is, let's talk about CUPS. It even talks about future of CUPS. But I've checked most of the answers, and I'd say they're 99%, maybe 95% accurate. Probably more like 99. I'm really impressed with the accuracy. I found few areas of concern. Okay, now better question, more detailed. What type of screen material is used for cups. And I made a spelling error there. Gee. I'm trying to copy it in case something goes wrong. All right, and so that's a follow-up question. Thinking about it. And there's the answer. The screen is for use for cups is high density polyethylene HCB screen of 40 to 50 mesh, equivalent to 384 to 438 micrometers. And then it shows you the reference also, reference 1, has shown to be effective, blah, 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 physical barrier. And, so it gives you the relevant answers, and you can ask for more information. So you can follow up down here and say, give me more, and so on. So that just shows you roughly how it works. And just try it out. I think I need to finish off here. Summary and conclusions then. Yield, fruit size, pack out of the primary contributors of high net revenue. And that's the big attraction of cups, because you get those in our cups. While rind defects significantly impacted marketability, but they were minimal in our cups because it gets such good protection from storms for one reason, and you get very little fruit drop. So we did a sensitivity analysis over these research years, and we found that fruit price had the lowest influence, fortunately, on revenue, but it is nevertheless important, mainly because it's an uncontrolled factor. It can change drastically, and there's no control over it. So it's a wild card. Cups prevents HLB, canker, and hurricane damage to citrus. It's a profitable method. It's been proven by now for growing citrus for the fresh market. Quality is similar to pre-HLB Florida fruit. Cups trees produce earlier, higher yield than conventional groves, and therefore they save input resources and costs by growing trees faster with higher production. The internal rate of return for CREC cups is estimated at 9% to 16% over a 10-year period. Again, these are questions you can ask the actual CUPSchat, and it comes up with pretty decent answers. You can ask it, what is the profitability? What is the internal rate of return? What is the break even, like I showed you? The HLB incidence in the CREC cups was less than 2% after 10 years. There's the link to our project site, makecitrusgreatagain.com, cups.htm, and then the Singerman and Schumann is the economics publication. So a few more summaries here. Design factors that determine the cost of a cups are shape and size. Costs per acre are less with larger, more square-shaped cups. 10 acres is a sweet spot for cups size based on costs of construction. Plantable space inside cups must also be calculated. It would be advisable to ensure a cup structure because it's expensive, and make preparations for storm damage repairs. Don't rely on contractors to be able to do it in a short time. I've seen every successful cups grower has a stockpile of their own repair materials available, usually stored in shipping containers. And they have a crew of people that can jump in and do the repairs. Then CUPSchat is a cup-specific AI tool that will help growers, extension agents, and researchers obtain instant answers and reports from 11 years of cups knowledge. Chatbot performance is improved with well-crafted prompts. Yeah, so don't try to use keyword searches like you used to using on Google. You have to actually write proper English sentences or phrases, and think of important words that will guide the chatbot to give you the answer you want. And there are actually there's probably university degrees being offered for that now. They call it prompt engineering. So it's a growing field of knowledge, and I'm not an expert at it, but I'm just mentioning it. Crafting of prompts is important. Verify chatbot answers for mission-critical questions. Like I said, get second, third opinions. And with that, I'd like to acknowledge all the following: growers, stakeholders, and cooperators, extension agents, laboratory and support staff, and all the various funding sources shown here. And I hope I haven't forgotten anybody. And with that, I'd be happy to take some questions if Mongi will allow some time.
We have time. Thank you, Dr. Schumann.
Great.
We do have a question in the chat. What was the seed count for the Valencia in cups?
Less than outdoor, I think, but it had seed. I don't know what the criterion is for low seeded or seedless. I think even seedless fruit are allowed to have a few seeds, but I didn't look at those criteria.
How frequently do you have to spray for pests?
Most people do it with monitoring, scouting, and driven by that. There are peak times for everything. Right now, it's peak time for mealybug. Very clearly, they love the heat and humidity. Thrips in the spring, especially flower thrips. Rust mites in the late summer. And so it wouldn't make sense to spray for everything all the time. So it's not calendar-based spraying. It's based on need. Yeah.
I'm just curious, are you finding anything on the horizon that excites you as much as grapefruit does, regarding cup structures and cups growing, as far as experimental varieties or top working over something that wasn't productive earlier, anything like that? What's the future, basically? What's the future?
Yeah. There are some real close candidates there, I think, close to grapefruit. But so far, I have not seen anything that will clearly match or outpace grapefruit. Although I haven't done the economics of it. Some of these other fresh fruit varieties, the easy peelers should be more valuable than per box, at least, than grapefruit. So we need to put our heads together maybe and look at that again. We keep doing it, in bits and pieces every now and then, but I believe something is real close. I'm optimistic. Anything, even quinoa, seedless quinoa, it's a wonderful variety. There's one that Peter chairs, I forget the name of it, that he mentioned just the other day that we were going to try. It looks like a high potential. We know very little or nothing about it yet in our cups, but something's going to come up. It's not going to just be grapefruit forever. I'm confident.
Very good. Thank you very much. Good presentation.
Thank you.
And the recommendation is to plant trees in the ground, not in the pots.
Yes, that is correct. We have never recommended in the pots. It was merely a research option that we couldn't contain our curiosity. Let's put it this way. We were so enthralled by what we saw in California. We went full out with it, but we realized it was too much management. Weed control is very difficult with it. It's not very water efficient. It doesn't capture rainwater like it should. So putting trees in the ground makes all the sense it should. Yeah.
Does break-even period include cost of land?
Not directly. It hasn't been I can tell you it has not been calculated. And when I say calculated, I mean estimated. We did estimates. I think you'd have to go back to the source article by Ariel Singerman, our economist, to be absolutely sure about my answer. But he may have included an assumption for the cost of land. I don't have that in front of me. You can ask the chatbot also. Ask it specific questions like that. It'll try to give you some answer. And if you please contact us, especially Ariel. He's the one that wrote that economics analysis.
I have another question. Do you do anything to improve the color of the fruit?
Yes, we do. The color of the fruit can be enhanced by minimizing fertilization in the fall, especially nitrogen. And so we do that proactively. The commercial growers do the same. The cups growers, they cut off most of their fertilizer by summer, sometimes even beginning of summer, as early as that. The last fertilization is sometimes May. And so the trees then coast on what fertilizer they've taken up already, and that's enough to ensure their needs, as well as to not over-fertilize the trees during that critical maturation phase, which is when the color break occurs. So that's been an easy discovery and practice that we've adopted. But some varieties will just never be a good color breakers in Florida. I mean, even outdoors, got nothing to do with cups, but W. Murcott just does not color up in the subtropical climate. Very difficult. And I think Mark, right now, he's on the call here also. He's done research on that, and with ethylene. So unfortunately, ethylene degreening doesn't work very well for those easy peelers. Mark can chip in if he wants. It works well for grapefruit, of course. Mark, you carry on. Yeah.
Yeah, we haven't been able to get color out of there. We tried ethathon pre-harvest even and post-harvest, and just it takes a long time, and you still don't get really good color.
So that's what we discovered. The best and cheapest way to do it is with horticulture. Just fertilization. Probably irrigation would also help if we have less control over that because of rainfall. The water requirements. But if you can cut back on water as well as fertilizer in the fall, it'll help. Basically, a bit of stress helps.
For everyone, if you need CEUs, send me an email. Again, thank you, Dr. Schumann.
Thank you. You're welcome.
Thank you, Julie.
And thank you, everyone. Let's see if
Thank
there's
you,
any last
Julie.
questions coming up here. No questions.
Thank you. Thank you.
Okay, thank you, everyone. Appreciate it.
Very good presentation.
I'll see you at Expo.
Okay. Thank you all for your participation.
All
And
right.
see you next time. Thank you, Julie.
Thank you, Mongi. Have a good day, guys.